Hi, gentlemen. Before introducing myself, I want to thank all scientific community to give us this opportunity to present my research paper in the future of information and communication conference FICC 2018, which held in Singapore. First, my name is Bromi Saeed from University of Hassan II. Today I will introduce my research paper entitled "The Strong Degree in a Single Valued Neutrosophic Graph." This work is supervised by Asiya Bakali, Muhammad Taliha, Florence Samarandak, Sima Mihra, and Manjit Singh. The plan of the research paper is presented in the following slide as following. In the first, I will present my objective. In the second, I will present some preliminary and definition. In the third section, I will present some definition of strong degree in single valued neutrosophic graph. In the fourth section, I will present a new definition called vertex strat membership, vertex indeterminacy membership, and vertex falsity membership sequence in single valued neutrosophic graph. In fifth section, I will present a conclusion, and finally the reference in section 6. So the objective of this paper is to propose or define different type of strong degree in single valued neutrosophic and introduce a novel concept such as the vertex strat membership, vertex indeterminacy membership, falsity membership sequence in single valued neutrosophic with proof and numerical illustration. In the second section, I will present some preliminary and definition. So, before introduce some preliminary, I will present a brief definition of phase logic, intuitionistic phase logic, and neutrosophic logic. So, the phase set is characterized by one part, strat. Phase logic handles the concept of partial strat, that is, the strat with a value between completely true or 1 and completely false or 0. So phase set represents the membership without expressing the corresponding degree of no membership, so it provides an imperfect expression of uncertain information. The degree of no membership in phase set is the complement of membership for phase set. Therefore, the membership is not independent. So a phase set cannot express the information about rejection. So this phase set is symbolized mathematically by the following expression, where the strat is between 0 and 1, and t is a function in the closed interval 0, 1. So, for more detail about this phase set, the reader can be consult the following reference. So, secondly, I will present the meaning of intuitionistic phase set based on the two compound, the strat membership and the false membership. So this phase set is an extension of phase set which describe vagueness and precision by a range of membership value. So intuitionistic phase set give a degree of membership and a degree of no membership of an element in a given set. And Tadanozov is the pioneer of this theory. He presented it to bring in a no membership. So this set is explained mathematically by the notation with the two membership called no membership strat and no membership called falsity, with where the condition of the sum of membership and no membership is between 0 and 1. So for more detail about this theory, we suggest the reader to consult the following reference. Next, we will present a theory which generalizes the previous set called phase set and intuitionistic phase set This logic called neutrosophic logic, which is based on a neutrosophy theory, we will describe or introduce what means neutrosophy. Neutrosophy is originated from neuter and sophia. Neuter means neutral in Latin, and sophia means wisdom in Greek. So neutrosophic means neutral thought, knowledge. This logic was developed to deal with uncertainty, including vagueness, ambiguity, imprecision, and inconsistency. So expert system, decision system, belief system, and tend to depend not only on the truth value but also on force and indeterminacy value. So current system which are dedicated to simulate human brain are constrained with strict conditions, whereas neutrosophic logic has its chance to simulate human thinking and to be utilized for real environmental excision. So this logic was introduced by Samarandak in 1994, and this logic is based on three compounds called truth and indeterminacy and falsity. So Samarandak neutrosophic set is characterized by three parts described as previously, called the truth, indeterminacy, and falsity. Truth, indeterminacy, and falsity membership value behave independently and they deal with the problem of having uncertain, undetermined, and imprecise data. So for more detail on this logic, we will consult the reader or researcher to consult the following reference. After the introduction of neutrosophic set, a new version called Single Valued Neutrosophic set, presented by Wang, described in reference 7. So the mathematical notation of single valued neutrosophic set is described by the following formula, where the three compounds, truth, indeterminacy, and the falsity is between 0 and 3. So for more detail about this logic, we consult the reference set. In the next slide, I will explain more what means neutrosophic logic. So, since everything in the world is full of indeterminacy, so the neutrosophic become appear and found their place into research. So the main idea of neutrosophic logic is to characterize each logic statement in three-dimensional neutrosophic space where each dimension of the space represents respectively the truth, the falsehood, and indeterminacy of the statement. So in an easy way, every logical variable is described by another triple TEF. In neutrosophic set, indeterminacy is quantified explicitly, and true membership, indeterminacy membership, and false membership are totally independent. So the following is a graphical representation of single-valued neutrosophic sets. So this table describes the difference between a fuzzy set, intuitionistic fuzzy set, vague set, and neutrosophic set. In this table, we say that fuzzy set and neutrosophic set although have three parameters. However, three parameters in triangular fuzzy number can only express the truth membership, and those in neutrosophic number can express membership function and indeterminacy membership and non-membership function, so they are completely different. An example of neutrosophic problem, we describe a series of numerical examples to explain well what means this neutrosophic logic, which will be used in the present paper. So, the first example, a vote with the three samples which are E, B, and D below is occurred, in which some votes are indistinct and it can't be determined if it is E, B, or D. This indeterminate vote can be expressed with neutrosophic logic. Another example, suppose there are 10 voters during a voting process. 5 vote yes, 2 vote no, and 3 are undecided. For neutrosophic notation, this expression will be explained in as well, 05, 02, and 03. Another example, if a dye is chosen on a regular surface, then there is no clear phase C, and Indeterminacy occur due to defects in creation of physical space of defective making of physical item involved in the event. Another example I will present it in the next slide about the cone. So there are many examples in the literature about neutrosophic problem. So where indeterminacy occur when we are not sure of any event. So in this picture, the situation is that the cone got stuck into the crack and still under its rolling edge. It has neither inclined to left or inclined to right, meaning neither the head touch the land nor the tile. In another word, as the cone stands perpendicularly on the land side, the crack, the percent inclination of head toward the ground is 0, and the percent inclination of tile toward the ground is also 0. So the event will be expressed in neutrosophic mathematical as following 0, 1, 0, and Indeterminacy. So briefly, neutrosophic set describe vagueness, imprecision, ambiguity, and inconsistent information that exists in real environments. Therefore, neutrosophic logic handle indeterminacy of information, while other approach neglect this point. In next, we have described a literature review of extension of the crisp graph theory, which will be used in this paper. So, in the field of mathematics and computer science, graphs are structure used to depict the pairwise relation between the objects from a collection. A graph can be represented as the following: G equal VF, where V is the set of vertices and E is the set of each connecting pair of widths. So in this table, I have described briefly the different type of graph. Crisp graph used by crisp theory, and their representation graph with two vertices connected with one edge. So in the second line or in the second row, a fuzzy graph which applied by fuzzy theory, where the edge and the vertex are labeled by a track membership. Similarly, in intuitionistic fuzz, we have two membership on vertex and on the edge. And finally, the single valued neutrosophic, which I have explored in the literature. I have applied the single valued neutrosophic theory on the edge and on the vertex. For more information about this single valued neutrosophic graph, which generalize all the previous graph, the reader can consider under reference. So some graph terminology which exists in the literature and which will be used in the following paper, and some proprietary which known by all the researchers. So the definition of my graph called single valued neutrosophic graph is the following, where edge and vertex are assigned by a neutrosophic number. So in the third section, we will present different type of strong degree in single valued neutrosophic, range from the strong degree of vertex in single valued, the minimum strong degree, the maximum strong degree, the total strong degree of vertex, the minimum total strong degree, the maximum total strong degree, the strong size, the strong order, and the strong constant single valued and totally strong constant single valued of degree. So this degree are extended from crisp theory, fuzzy graph theory, and intuitionistic fuzzy graph to be working on single valued neutrosophic graph. So the definition of strong degree of vertex in single valued neutrosophic graph is described in the following formula by three degree by 3 strong degree of vertex. The strong degree based on trust membership, the strong degree based on indeterminacy, and the strong degree based on falsity. The minimum strong degree of single valued neutrosophic is defined in a similar way as a 3 minimum strong degree of G. Also, the maximum strong degree of single valued neutrosophic is defined as following: as 3 compound, a maximum strong degree for trust membership, a maximum strong degree of indeterminacy, a maximum strong degree of falsity. So the total strong degree of a vertex in G is also defined as the degree as strong degree of vertex plus the value of vertex for the trust membership, indeterminacy membership, and falsity membership. Next, we have also defined the minimum total strong degree of G as following. Also, the maximum total strong degree is defined as following. So, finally, we have defined the strong size of single valued neutrosophic. So, the strong size of single valued neutrosophic is defined as three strong size of trust and trust membership, and for indeterminacy membership and falsity membership. So the stronger order of single valued neutrosophic is defined as following. So next, strong constant single valued of degree and total strong constant of single valued of the single valued neutrosophic is defined as following. So if strong constant single valued neutrosophic equal, we call single valued neutrosophic K1, K2, K3 strong constant single valued neutrosophic, the same as totally strong constant single valued neutrosophic. So from this definition, we have derived some properties which is described in the following table. In the next slide, or the 5 section, we have defined vertex trust membership, vertex indeterminacy membership, and vertex falsity membership sequence in single valued neutrosophic. We have 4 definitions. So the definition of the vertex trust membership sequence in G is defined as following. In the definition, we have defined the vertex trust membership sequence, which we have the following properties. So, not if vertex trust membership sequence XE is repeated more than once in G, say R different 1 times, then it is donated by the following symbol in the sequence. Similarly, we have defined the vertex indeterminacy membership sequence as similar to trust membership, and this also for falsity membership sequence. So finally, the 3 definition will be clubbed in one definition in a single valued with vertex in has vertex trust membership sequence and vertex indeterminacy membership sequence, and for vertex falsity membership sequence in same order. Then it is said to have vertex single valued neutrosophic sequence and denoted by the following symbol. In the right, we have you have an example of vertex single valued neutrosophic sequence as a 3 vertex single valued neutrosophic graph. In conclusion, this paper, the idea of strong degree is imposed on the existing concept of degree in single valued neutrosophic. After that, we define the vertex trust membership. We define the vertex membership, indeterminacy membership, and vertex falsity membership sequence in single valued neutrosophic with proof and suitable example in the next research. The proposed concept can be extended to labeling neutrosophic graph and also characterize the corresponding properties. So for reference, we have the following reference. So for more information about this theory called neutrosophic graph or single valued neutrosophic graph, I invite the researcher to consult the neutrosophic set and system an international journal in information science and engineering in the following website for more detail about neutrosophic sets and their extension and their application. So thanks for your attention.